this one. So let's start. And please have your questions ready for discussions, from homework, from web assign, anything you want. A function is continuous from the left or from the right if equal to, it's okay if you're wrong. So we are just here, we are enforcing the concepts. So function is continuous from the left. So let's just say from the left for now. If
the limit as the function approaches that value from the left equals the same from the right.
Playing games.
Equals,
Or
if this equals what?
The limit of f of x.
Careful.
X approaches a from the right.
No, that's not going to be continuous from the left.
The value at a?
Yes, exactly. So I'm going to erase this so it's not confusing. Just one or because it's the same thing but from the right. But I'm just going to erase one, the right one, so it's not confusing. Because maybe that confused you. So let me just make it very clear. So sorry about that. So a function is continuous from the left if the limit from the left equals the function value at that point. Awesome. IVT, the intermediate value theorem, guarantees that a of a function guarantees a of a so let me see what I wanted to say here. Intermediate value theorem guarantees that a function must have a, what did I mean?
Is it like an interval of a function?
No.
A continuous function must have a point in AB.
A continuous function must have a, thank you. That's what I meant.
I said point, but I meant value. Have
A value, yes. No, but must have a zero or an x-intercept. 0 or x-intercept. Good, awesome, thank you. IVT finds the solution or shows there is a solution in A, comma B.
It shows.
Exactly. It only shows. It cannot determine. It only shows that there is a solution between A and B. And this must be a unit interval. Good. Awesome. Thank you. Limits at infinity. Look for asymptotes. Limits at infinity.
Horizontal?
Yes. Horizontal or slant. They're not the same. This is horizontal and this is slant, or this. Okay, awesome. Infinite limits determine whether the function has
horizontal or vertical.
Careful, it cannot be the same. So limits at infinity means when x approaches infinity or negative infinity. Horizontal and slant, they cannot be the same.
Vertical?
Yes, only vertical. Yes, awesome. So infinite limits, if the limit is infinity, it means that this is a vertical asymptote. Awesome. Functions can or cannot have two different horizontal asymptotes.
they can.
Yes, absolutely. They can. And we had an example from last time. Here is a perfect example with the arctangent function. Arctangent has two horizontal asymptotes. one at positive infinity, which is pi over 2, and the other one at negative infinity, which is negative pi over 2. So this is a perfect example. Okay, the square root of 16.
4.
Plus or minus 4. No, sorry.
Okay, do I need to explain this again? It's in the notes from last week. From Monday, sorry, I think. Do I need to explain this again? Yes or no?
This is the square root of the absolute value of 16, is that correct? Is that how it's written in the notes? Sorry.
I no longer have the notes from Monday. I recycled them, but they are posted. So again, do I need to re-explain the square root of 16? Or can you look at the notes from Monday?
I'll look at the notes.
Okay. Good. Next, the square root of x squared.
Absolute value of x.
Thank you very much. Which remember, please remember, it's x for x greater or equal to 0 or negative x for x less than 0. Awesome. We've seen 3 indeterminate cases so far.
0 over 0. Infinity over infinity. Negative infinity over negative infinity.
It doesn't matter. The sign is not important.
Okay.
I couldn't.
Infinity minus infinity.
That's it. These are the 3 that we looked at so far. Awesome. F prime is or equals the of the. So let me help here because it's too ambiguous. So F prime is or equals the instantaneous rate of change of the function. Instantaneous. GE of f of x. But this is very important. There is a condition here, right? Where the function is continuous and no cusp, corner, or vertical tangent. In other words, where the function is differentiable. Good. Again, we talked about this before. 2 mandatory steps for finding f prime. Let's write a definition, first of all. Can anyone remind us what is the definition of f prime of x? There is only one definition.
Is it the derivative?
Yes, but what is the definition? Correct. Yes, f prime is the derivative, but what is the definition?
Limit.
Yes.
H approaches 0.
Yes, of the difference quotient. Awesome. Yes.
Yeah.
Thank you. Brilliant. Thank you. That's all I needed to hear. That's it. There is only one definition for f prime, and this is it. 2 of those important concepts put together, the difference quotient and the limit. Awesome. 2 things have to happen here. So forget about the limit for a moment. For the difference quotient, what are those 2? For any function, when we determine the difference quotient, 2 things have to happen.
The variables must cancel?
No. Not the variable or the variables.
H has to
Careful.
be...
Careful. That's the second one. The first one.
Is that terms with x have to be canceled out of the numerator?
Without age,
Or
yes. Terms
without age,
without,
thank you.
yes. Without age must cancel in the numerator.
Without H.
Awesome, thank you. Now, the second one needs an adjustment because we have the limit, okay? So the second one would have been simplify this h. So the second one is still simplify h in the denominator That has to go away. But if you want to add the third one, we can add the third one here. In the final answer, f prime of x, final, cannot have h at all. At all. So when we only look at the difference quotient, all terms without h from the top have to go away, and this h must go away. But the final answer still has an h in it. Not anymore. When we add the limit, there is a third step. The third step, the final form, can no longer have any h in it. We're going to discuss this in some examples today, and you'll see 1, 2, 3. A function has a derivative at a point if f of x is number 1 is
continuous.
Yes, awesome. Okay, and it does not have
A cusp,
corner
okay.
or vertical tangent. Awesome. Please remember, the derivative does not exist if the function is not continuous at the point. It's not continuous at that point. And even if it's continuous, if it has a cusp, corner, or vertical tangent, f prime is not defined. So it has to be continuous in addition to continuity, no cusp, no corner, no vertical tangent. Okay, last one. I know this was a long one. A differentiable function must be continuous and have no cusps, corner, or vertical tangent. True or false?
True.
Of course, we just talked about it a second ago. Good, so a function is differentiable only if it's continuous and does not have these that we just discussed. Okay, awesome. And now I'm ready. The floor is open. Anything you want to ask, anything you want to go back to?
Could we look at number 28 from the homework?
Yes. I don't remember what it was. I don't have solutions yet. So if you want to tell me what was, which, this is from 2.5, 2.6, 2.6, 7.
This was from 2.7, I believe.
2.7, 28 into 2.7. Okay, 28.
Sorry, I believe it's 2.8.
Oh, thank you.
No worries, 2.8. No worries. So it was 28. Okay, so this is, I'm going to change it into f of x. It's easier for me to write and for you to understand. Is this the function x over x plus 2, f of x, or f of v, doesn't matter? Yes?
Yes.
Okay, perfect. So I have to find the derivative. I have to start with the definition. What do I write? It's okay if more than one person will say it at the same time. It's fine.
F of x plus h, are you writing the definition for?
That's not the definition of f prime. We just wrote it a minute ago.
Is it limit as h approaches 0?
Yes. Two concepts together. Please remember, two concepts together. Good. So now this is f of x plus h minus f of x over h. Awesome. I'm sorry about the noise in the background. Let me see if I can do something about it because it may annoy you. So let me just try for a second if I can turn that off. Okay, I did, so we'll see what happens. I hope I did it. Good. So now I copy the limit as h approaches 0. Can anyone give us f of x plus h? Let me not write here because it's not enough room.
X plus h divided by 2 plus x of x, 2 plus x plus h.
Excellent. Awesome. Okay, good. Over h. Good. Next. Please do not drop the limit operator. Please do not drop the limit operator. If you do, it's wrong and you will not get full credit. Please put a note somewhere in your notes that you're going to use. Put a sticky, whatever you want to do. Do not drop the limit operator till we apply it. We have not applied the limit operator yet. Good. Now, the next step. Can anyone tell us what will be the next step here? I have to copy the limit operator till I apply it. We had a, yes, awesome. We had a similar example in the previous notes. We identified the difference quotient for several functions: quadratic, rational, radical. All we have to do now is just put these two together. Can anyone give us the least common denominator?
X plus H plus 2 times.
Very good. Yes, awesome. That's it. What is the adjustment needed here? And what is the adjustment needed here?
Multiply the denominator.
So to speak. Yes. It's not cross multiplication rule, but yeah, you can say.
No, not cross multiply, but it's like,
yes,
like that.
Perfect. Good. So I have x times x, which is x squared. I have x times h, which is xh. I have 2 times x, and I have 2 times h. And then minus x times x, and then minus x times h, and then minus x times 2. So back to our notes. Number 1 has to happen. Terms without h must go away. Do they? If they don't, we have a mistake somewhere. So let's see. In addition, there may be more terms, but at least all terms, minimum. The terms without h must go away, and they do. So I see 2h, this is h over 1, and I have to flip the denominator because I'm dividing. Do not drop the limit operator. So then I have the numerator, which is 2h, and the denominator now becomes h, x plus 2, x plus h plus 2. I didn't say from the beginning, let's plug in 0. Oh, well, of course, it's f of x minus f of x will be, which is 0 over h, of course. For the difference quotient or for the derivative, there is basically no need, but because it will always be at 0 over 0. Okay, so condition 1 happened. All terms without h are gone. Condition 2 has to happen. This has to go away. If it doesn't happen, something is terribly wrong. Does it happen or not? Anyone?
Yes.
Yes. So here it is. And now condition number 3. I will drop the limit operator at this point. This is the only time, just at the last step, when I drop the limit operator, because I'm applying it. I have not applied it here. I have not applied it here. I have not applied it here. And I have not applied it here. It has to stay. So now please apply the limit and tell me the answer.
2 divided by a plus 2 squared.
X plus 2, everything squared. Awesome. That's it. So at this point, we did apply the limit. So as you see, number 3 happened. In step number 3, the first derivative can no longer have h in it at all, and it does not. Why? Because we applied the limit. Any questions, please?
I sent a message in the chat.
There is no conjugate because these are not radicals. We use conjugates when we have a radical expression that we want to rationalize. Anything else? Other questions?
So you said in the prompt it says to at the end replace x by a. Is that a
yes,
necessary step?
because I didn't get the chance, and I will today, right now. Yes, in case the question was asking us to find f prime of a, and let me explain that. Perfect question. So 1 second.